Okay, hello everybody and welcome to the webinar How to Create a Complete 3D Model of Building Interior and Exterior. Are we ready? Today with you, with Peterman and Matthias Zupan, we'll be showing you everything you need to know on how to do the mapping of a building or an object from the outside and the inside. It is a combination of two methods, photogrammetry and SLAM. So a bit more about the specifics of this project. Here is the today agenda. So at first, we're going to have a quick poll to warm you up a bit, and then we'll tell you about the project, and then we'll go over first the photogrammetric part to start on the familiar grounds or air, and then go to the SLAM part, the interior, and then we'll see how these two data sources intertwine in 3D survey, and we'll tell you a bit of why that might be a good benefit for you. So, are we ready to break the ice with some questions? Too bad you're all muted. Let me just share these questions with you. All right, question number one. I guess you never get tired of this one. Yeah, are you already a 3D survey user? So, okay. Votes are coming in steadily. And some late attendees still joining. We got a pretty good number today. I see this is quite a hot topic. So glad we made this webinar. And let me give you just a few more seconds to cast your vote. If you haven't found it, it's well, it should be
in
obvious.
the middle of the screen.
Yeah. Okay, I think we're
so now 77% of people have voted, so we can close the poll.
Yes, and here are the results.
So are you already 3D survey user? So this is a pretty specific topic that we are presenting today, and I think it's very interesting for 3D survey users. So a lot of you are now, so because of that, I think it's quite normal to have most people who are joining today already using 3D survey. But a quarter still are not yet 3D survey users, and also for you, I think this will be an interesting webinar to show you some advanced functionalities in 3D survey.
All right, and because this is a the topic today is heavy on SLAM, we have a bit more specific question for you. These functionalities, SLAM-wise, are covered in 3D survey scan module. So we would like to know, are you already using 3D survey scan module? This is the module that brings you point cloud registration. It brings you X-ray views. It gives you some additional abilities of visualizing those point clouds. It gives you the ability to produce a point cloud-based orthophoto and a few other minor stuff. With what did I forget? I think there's one pretty good.
Automatic line detection, things like that.
Yeah, it's a good one. Yeah, you'll see all that stuff today. So for those of you who are still on the no side of the answers here, you may get a nice overview of what you're missing out on. So let me give you just a few more seconds to answer. 3, 2, 1, done. And here are the results. What do you think?
Wow, so I see that most people have not yet tried the 3D survey scan module. So the scan module is most useful if you have a SLAM or a light or terrestrial LiDAR scanner. So based on our previous polls, we were asking you guys also, do you already use SLAM or LiDAR? Most of people are not using it yet. But here we can see that 20% are already using 3D survey LiDAR module, and 15% have tried the trial. So that comes together to about a little more than 1/3 of people who have tried this functionality already, and the rest have not yet. So there's still time. This field, I think it's evolving very fast now. The SLAM devices are becoming more affordable and really also more powerful. I think in future this will be an interesting tool for land surveyors, if you ask me.
Okay, let's just have one last question and then we'll take over, I promise. So very in line with the previous question, are you already using a SLAM device? So do you have some sort of SLAM scanner? Do you produce point clouds with it? And you don't know what to do with them, maybe? That's where, you know, scan module would benefit you greatly. So the votes are coming in, and this time it's really tight. If this was election, I would say every vote can decide whether we go on the red or the green bar. So I think majority of you have cast your vote.
Okay.
And here are the results. As I said, very tight.
Yes, I'm also surprised at the number of yes votes. So the new SLAM devices, which came around about 1 year ago, I think these ones are now really powerful. And I see that half of the users today are already using a SLAM device. So I think that's a pretty high percentage, even though this is a webinar, which is dedicated to SLAM users. But still, almost half of you already own SLAM device. So that's interesting to see. What do you think about it, Mattia?
Yeah, I think if with every webinar that has a little something to do with SLAM or, you know, LiDAR stuff, we increase this number for, I don't know, 10 or 15%. So it is a really interesting topic. I mean, really interesting part of the field. So yeah, it's picking up, and I think it has its very strong part in the future of mapping and surveying.
Great.
So yeah, I think we can hide the poll now and go back to this PowerPoint. So yes, here we are. Oh, sorry. So this is today's agenda, and as promised, a little something about this project that we will present this workflow on. Here is with Peterman with you know, the background.
Okay, so also these SLAM devices, they are very interesting to us. So we try to make 3D surveys so that it can work with different kinds of data. And the best way to make 3D survey really versatile is to actually use it on real world projects. So for this project, we collaborated with our National Building and Civil Engineering Institute. So they are actually almost our neighbors here, where we have the offices. And they have this interesting project where they are developing new circular construction practices. So their project, it focuses on renovating old buildings so that most of the materials can be reused or recycled instead of filling some landfills or these kind of things. And with that, so their approach is to establish digital tools for material tracking, which will help in this case. So they achieved that by creating special BIM models, and they are doing a lot of interesting work on the subject. And where we cooperated was in a pilot test study on this real-world example, where we have this old prison building in Maribor, which will now slowly be renovated and made into new startup offices and these kind of things. I think part of it will also be a hotel. And we were working together on this project to help them make the 3D model. So Mattia, can you go to the next page, please?
Sure.
Okay, so the goal of our collaboration was to create an accurate 3D model of the building. So from that 3D model, so then the National Building Institute takes over. They also have our 3D survey software. And from the 3D model that we helped them make, they then extracted a wireframe of the building using our 3D survey. And then from that wireframe, they create a BIM model in the BIM modeling software. We will talk more about how that BIM is created. And then into the BIM model, what they do is they enter the wall and floor compositions. They get those compositions by taking samples of the walls. So they have people going through the building with a hammer and pickaxe, and they take out different sections of the wall. Mattia, can you go back into you're the presenter today.
Sorry, I don't know why I fell out of that one.
Yeah, so for each wall they take out the composition, what percentage of the wall is brick, what is wood, plaster, etc. And then they use that information in the reconstruction to best plan the whole reconstruction phase. Can we go to the next slide, please?
Yeah.
So the reason that an accurate 3D model is needed, because that allows them to create a precise inventory of materials, to list all the different materials, and that forms the basis for the reliable materials cadastre for the whole building. This will allow them to make informed decisions with exact data in material types and quantities. They also work on creation of digital building passports, which then list all those materials and help track how the materials are used, and try to use as much as those materials as secondary raw materials across the whole value chain. The main goal is to increase the efficiency of cost savings of the building renovation projects. Right.
All right.
So that's about the basics of the project. Now let's talk a little bit more about how we went and how we collected the data. And now back to Mattia, please.
Yeah, on that part, we prepared a short video for you to get a bit animated. And I will run it right now. So it should pop up on your screen. Here we go. So first of all, we went and flew our drone to create a photogrammetric 3D model of the exterior of the building. So this is the premises that we're interested in. We took off at the parking lot, of course, and here we can also see where the images were taken. And this is our part of the building that we were interested in. So this is the exterior, and we also did the interior as mentioned. So now we go inside. You see, this is a very complex point cloud. So how did we get this one? With StoneX X2 Go SLAM scanner. We started outside because it is very important if you want to have a precise location information. So to have it georeferenced, you have to be outside let's say half the time. And then we just walked inside in one uninterrupted walk, like the machine was running, and we just, took it for a walk, floor by floor, room by room. And as you see, this building is not the prettiest one, but it makes an interesting case. That's life. It's not always pretty.
So yeah,
But
it is an ex-prison.
it is an ex-prison after all. So yeah, we had to be careful on some parts of it, and it's really easy to maneuver through the stairs and all different parts of the building with just this small device. Anyhow, when we ended our stroll through the building, we got the results when we got back to the office. So here's the point cloud. We also got the spherical images, which help a lot in inspection. You can read this beautiful graffiti also on them. But it's not just for viewing purposes. You can also do some measurements right on the images, the spherical images, because they're all connected to the underlying point cloud on which the CAD elements snap to. So this is one great way to investigate, to inspect the images, the digital twin of your area of interest. So this was the video. And now let's focus a bit more on the photogrammetry part of it. So here, yeah. So here is the slide of the photogrammetry. So we recorded everything with the DJI Matrice 4 drone. It was just after we bought it. The project was done very briefly, like 10 minutes of airtime, 215 images, and it was done in manual flight mode. We took circular paths around the different building parts. We decided to go with the whole building, even though not the whole building was part of the project, but it didn't, it made like 5-minute difference. You could also map this in oblique mission. It would also be good, but you wouldn't get through with it with just, let's say, nadir images, just top down.
How do you think that flying in manual or orbital flight like you did here, or using the oblique mission plan, how do you think that compares?
I would say it's
quality and yeah.
I would say the main variable is the pilot itself. If you're experienced pilot, go for manual flight, because you know what you need to take a picture of. You have the idea about overlap, and you take in account all these variables, environmental variables. But if you are, let's say, maybe a new person on the field of drone mapping, just choose a predefined mission, oblique mapping, and it will also be good. Maybe you'd get this way, if you use the predefined mission, you'd get a bit more images, so it's a bit heavier on the processing. That's why we also decided to go with manual to just get what we needed.
The model is still very detailed and very accurate. So if I just add my 2 cents, I think a good option for mission planning here, also very powerful thing, it could be just to fly in the orbit mode, where you just fly the drone in the middle of the point you want to record, select orbital flight, move the drone out, and when you move the joystick into the left, the drone starts to make a circle into the left, so you don't have to think about so much about all the navigation, how to put both joystick sticks. You just do everything with one joystick. If you want to learn more about it, check it on the YouTube. It's very easy to use and very powerful, I think.
So yeah, as mentioned, I think this point cloud came out really great. We got a lot of detail out of it.
Yeah.
And yeah,
And this is only 200 images.
Yeah, if we wanted to have, I don't know, even denser point cloud, we could also add some grid mission on top of that. But I think this is more than enough. It's, yeah, I would say we did a really good drone job.
Okay.
So yeah, I think that was that's all there is to about the drone part, and I think we can go back to you with
Okay.
the SLAM
I'll
part.
make myself the presenter.
Okay, go ahead.
And show my screen. And I think you can already see my screen by now. Let's go into presentation mode. So now I can talk a little bit about the hardware that we use to record the insides of this building. So as Mattia already mentioned, we use this time StoneX X200 Go laser SLAM scanner model. So we chose this one based on its specifications. So what we were looking for was to get a dense point cloud from it. And this one creates a very dense point cloud. It records about 600. So it's down here, 640,000 points per second. So for the whole recording, we got in total about 700 million points, something like that, after initial processing. So it achieves that because it has 32 lines. It has 32 line scanner module. So that then tells you how many points it will record per second. So in there are 32 small SLAM scanners, basically.
How about accuracy?
We think it also affects the accuracy a little bit. So in the last year, a lot of different SLAM scanners have come onto the field. This one produces accurate results continuously when we do projects like this, when we combine insides and outsides. So they tell me that this also comes down to what kind of SLAM algorithms are used, how these sensors are utilized. This SLAM scanner, it has a very good relative accuracy. So with SLAM, the information that we got from the sellers of this, they told us when you do the scanning, 50% of time you should have RTK. If you want high absolute accuracy, then you can move inside. And after you do the inside scan, you go out again and you walk outside again, so that you have like, so you don't have a blind polygon, but you have georeference information. Then for a while you rely on the SLAM only. And then when you come back, you go back out again to get the georeferencing back running.
So you're saying you should also close the loop?
Yes, basically. So you don't need to close the loop by placing the scanner on the same point again, but you can move outside again and walk over the same area just to increase the accuracy a little bit. One of the benefits of this scanner was also that it records the 360 panoramas, which can then help with the creation of 3D models, because you will later see that we also get those 360 panoramas. And if you're not sure how to connect the walls or something like that, you can move inside the 360 panorama and see better how the room was composed.
Okay. Those with good eye maybe see that this one doesn't have the RTK antenna attached, but that's
this is the
optional.
screenshot only.
Yeah.
Screenshot only. When we went out, we mounted the RTK antenna onto it and connected it to our N-trip network.
Okay, right. So can we see a bit of the project now? How
Let's
did you
go here. And here now I have the merged project. So this is the one that Mattia was also showing you. If we enable the bounding box and go in here, we can see that now we have together the SLAM and photogrammetry. And if we go
okay? Maybe just before we go forward, I guess people will wonder, how did you get the inside indoor scan point cloud into 3D survey?
Good question. So because everything is geo-referenced, it actually aligns quite nicely automatically. So the mapping of this site, I think the SLAM part, it took us about 30 minutes. So a little bit of walk outside first, then we went in and had a stroll through the whole building. So we went down here for maybe 5 minutes and walked through the basement of the object. And then we went into the ground floor and had a stroll through the ground floor area. And then we went up the stairs and into the first floor. So upwards floors are a bit smaller. So when walking, we just walked like that along the wall, went into the building here along this wall, back through the walls and like that, making sure that we walk through every single room when doing the mapping. So it does get a little bit tricky. Here you see you have the doors here, the doors there. You have to watch where you are going, and but we did a good job because we managed to record all the rooms in one go. Right, and then here we are already at the top floor of the building. We walked here. As we said, the whole mapping, so that's SLAM and photogrammetry together, it took us about 1 hour of work. So it's a pretty speedy approach to the building mapping. Right. So then comes, so now we have the 3D model in the form of the point cloud. But you know, as usual, for the more advanced things like BIM modeling, we need the final model where we can enter the building inventories and these kind of things. So for that, we still need to process the model a little bit. And now I'll just go ahead and I will close this window and we will go to this one. So now for the extraction of walls. So one way how to achieve that extraction could be we could create an X-ray in 3D survey. So these were the functions that we were showing earlier. You go into the point cloud. So here we made directly the section in the point cloud, and then you would go X-ray view and you would calculate new X-ray views. So in that case, you get this kind of top-down views. And then here you can enable the point snapping, and then we can create, we can improve on the design like that, because so here we would go into automatic line detection. This would give us this kind of lines, and then we need to improve on them. So then I can already maybe give you a little bit of heads up. So here we're still doing this completely manually, but in the next versions, maybe some additional tools will be coming, which will speed this work up. But actually for this project, where we need to extract the wireframes of the walls, we did not decide to use this approach for one important reason. So here, the institute, they need the BIM model. And one thing about BIM model is they need to have, if the room is approximately perpendicular, they need to have perpendicular angles in this room. And in this case, using just the simple CAD section of 3D survey is already super beneficial. So here now I have a project where I only have the top floor of the building. So for this demonstration, we'll just be focusing on the top floor of our area. So now to help with the digitalization, we will just temporarily use the bounding box and like so that we have about 2-meter high section of our building. Let's clear this one now. Now, the digitalization was done by the institute, but we helped them, we talked with them and tried to discuss the best workflow for them. The workflow we came up with is the following. So we go into CAT, and here we will extract the wireframe. So here it's important that the wireframe itself, it is made out of perpendicular lines, so that also the whole BIM model will be made with such perpendicularity. Now, how we will achieve that? So first, we will define our floor plane. We go here and we click define plane, and here we will select elevation in the middle of the main floor. Click to select. If we define plane like that with 1 point, what we get is a horizontal plane. I will confirm this plane now. So now for the second thing.
This plane basically does what? It enables you.
It now makes sure that the plan that I will create, or the whole floor plan will all have the same elevation.
Yeah, so it's locked basically. All vectorization is locked on this plane, on this height. Yeah.
So now we will define the perpendicularity. So we will take the longest line here, so this longest corridor. We will draw the line and take point here on the wall for the starting point of our angle, and here we will take the final point of our angle, like that. And now we'll use this button, or we could also click F8 on the keyboard. This now locks me so that I can only draw in these two directions, in these two perpendicular directions, like that. Clear. I can temporarily delete this line now because we no longer need it. And now we can begin digitizing, for example, these rooms.
So it's like combining AutoCAD and photogrammetry software.
So it's similar approach as in AutoCAD. So when learning AutoCAD, drawing in AutoCAD, sometimes it's easiest to start by drawing only perpendicularly. So here we can now see how we would then extract this wall information from this model. So I will go here. So while we did all of that, I could try to select the point down here in the corner, but that is sometimes tricky. Instead, I can take the point up here where I can clearly see where the wall ends, and I will click here. Automatically, the point is then projected down there on the floor. And now when I go into this direction, again, I don't need to take the position here, but I can actually take the point here on the wall. I will click here, and now I already have this wall digitized with high degree of accuracy. And now for this side,
because you use the plane.
Yeah, and now I will actually snap in the middle of the wall here, and that way we get this. And then we can come here to the roof. So actually, what I can do is I can here we will go here and this section. And then the same way we can create this wall section here. We select the point there and then just go to here and to here. And then in this direction, to extract the thickness of the wall, we can click on the other side of the wall section like that and continue back here and here. And you can already see like that, the digitalization is a lot more user-friendly, because we don't need to take the points exactly on the edge. You can just click on the other side of the wall and snap to that. And we go back to here and then to here.
And anytime you want to inspect something that looks a bit, fuzzy or sparse on the point cloud, you can enter the sphere and see it on the image, the spherical image.
And there's that. So if we select the select tool now, double click on the spherical image, you can move in and see how that area looks on our view, like that. So one thing to note with those spherical images, the things that are very close on the images, they are typically a little bit
distorted.
Yes. So you should sometimes, to get the better view of this wall, you should take the image further away.
Yeah, so when you try to decide whether to trust the image or the point cloud, you would say the point cloud is a better
so yeah,
information.
The point cloud in this case is the accurate part. The image is used as visualization tool to better see the composition of the room, to see things that the point cloud is missing.
Okay,
because sometimes yeah.
So this way, basically, the whole vectorization was done. If I may return a step backward, so what about the case if the point clouds didn't align perfectly? Is there a way to save this, to do something about this in 3D survey?
So you mean, let's talk about the additional tools inside 3D survey.
Yeah, because probably sometimes you have some accuracy problems and you have to do some manual tweaking or.
Okay, so in this case, we were relying on the RTK for georeferencing of the SLAM data, but sometimes you don't use the RTK. So in that case, 3D survey also comes with tools for manual registration, which allow you to find, to align point clouds based on the identical points. And also, you also have the ability to use the automatic registration. Automatic registration we use if we have 2 point clouds over the same area, which are already approximately georeferenced. And then you can use the automatic registration before, where you still have the multiple point clouds in the project. And you can use that to georeference the 2 point clouds together. So these are additional tools that are part of the LiDAR module, and which allow you, scan module, and they allow you to do some additional things. Right, so here they did this like that. They also took out from the model the heights of the rooms. So in this case, I think that the workflow they used was then to do the higher model. They just used bounding box. We'll now take this one in like that, move this one to the top, like that. So here, actually, so the BIM model that they are creating, it actually does not allow creation of arcs like that. So the trick they used in their software was to calculate the average height of the roof section. There is a neat trick that allows you to calculate an average height of this kind of roof model. So we'll achieve that by moving bounding box up here. Then they went in and they selected the points inside of this roof section, like that. So before I do that, I should press escape and go into top-down and ortho mode, so that when I do the selection, I only select points within my polygon.
Within the ceiling.
Yeah. So without the wall section, like that. go out of top-down and ortho. So now we want to know the average elevation here. We'll use this trick, manipulate points, average height.
Because the beam model,
because the beam model they are creating, it can only be made out of flat sections. So for the elevation, they then used this elevation of the building model. So we go back to bounding box like that. And then from here, they then extract the height of the, so have to disable that, go into cat. To get the exact vertical distance here, what we will do is we will create a new plane here upside, confirm, and then to get this exact point up there, we'll just do like that. And if we now want to draw this, we can create a point here and draw a line up here. And this is now the elevation, which was then used for the creation of a wireframe model of this building. Of course, they did a little bit more work, but even with all the work, the whole building was done smoothly. So some people actually go and they make BIM models directly from the scan data, but in those kind of approaches, it's a little bit harder because you have to work a lot harder to fit the walls onto the point cloud data. But like this, if you extract the wireframe efficiently from the model, you can create the whole beam model then more efficiently.
Yeah, one alternative way, perhaps the way I would do it, is you could also still do it in X-ray views. You still have the ability to draw perpendicular lines on there, and you just make section out of each floor, out of each level, and then just connect them vertically. And this would be my approach, but I guess that's the beauty of 3D Survey. You have so many possibilities about going about your project.
Yeah, I think here one of the reasons we went with 3D is because some of the rooms are pretty, so they are quite hard. So in X-ray, you take the whole, you then get a lot of these lines. So here they were able to do that and then do the best kind of the model from that, taking into account all the small details and making the really accurate 3D model out of it.
All right.
Cool. Okay.
So what would you say are like the great benefits of this method if we sum that up?
So I have here a slide which will help me to repeat that. So here what we think are the benefits of using 3D Survey on this project is we accelerated the whole project process. So one big advantage was to use SLAM for the capture of data outside. So it allowed us to speed up creation of the whole building model with only 1 hour of field work. And then there's also the cost efficiency because we streamlined the 3D model generation process. Then less time is needed to create that accurate 3D model, which reduces the labor costs, and it also reduces the technical expertise needed to create this kind of 3D model. Because here you saw that the line drawing with 3D Survey is a very straightforward tool, and it allows you to work very fast. And finally, it allows us to have the scalability of this project and replicability, so the whole process can be repeated also on other buildings to make it easier. And make it easier to approach to other projects, which will broaden this project's impact.
Yeah,
right.
Sounds great. So let's say if we compared this method to like what are the alternatives, if you went in traditionally and measured these distances in rooms, this seems
With
like
this
forever.
the other thing would be, I'm not sure how accurate results we could get from that. Another option would be to map all this with the terrestrial LiDAR scanners.
Okay.
Maybe you could finish in one day, but I'm not sure if you would. So maybe you would get, instead of 1 hour, you would get maybe one day or more of work. But that would be it would be a good alternative option, but you would have to use more expensive hardware and it would take you more time. So it would make the project more expensive.
And we have seen that practically the whole post-processing, the vectorization part was done all in 3D survey. So there was no need to, go to AutoCAD or something, except for at the very end when you export stuff to generate BIM models.
Yeah, so BIM software, this is still very highly specialized software. So the final BIM model is then generated in that software where you just select the footprints and you add heights to get the walls, and then those walls connect together and you get the base plate, floor base plates and these kind of things. And then they then add the inventories and the database of all the materials and stuff like that. Right. Maybe let's have a look at what our viewers think.
We could go. Yeah, we could go to the files.
Let's see what kind of questions did we get today.
Okay. So the final slide is about the questions.
I see. So here we have some.
So if you still have questions, you still have a few minutes to pop them in there and we'll do them.
But in the meantime, I see here is the first question.
Issues,
the first question says, are you calculating the point cloud in GPU data center, or do you have your own graphics cards? How long did it take to calculate the point cloud of this prison? So in this case, we did two calculations. So the first calculation was the photogrammetric part. The photogrammetric part, it was all done on desktop computer, regular desktop PC. We had about 200 images, and I think the whole calculation took about 2 hours of processing. So here we also took less photos to get to the final result faster. Then for the second part, which is SLAM processing. So for SLAM processing, for the raw processing of SLAM scans, you put it into the software that comes along with the SLAM scanner. Again, the part of calculation is run on the GPU. And again, you run it on your local desktop computer. This time, I think we had a bit over 30 minutes of the scanning time. The calculation, the processing of raw data, I think it took about, I would say between 8 and 12 hours, something like that.
Okay. So the SLAM processing is still done in a separate, like a native software that comes with the hardware. And after that, it's imported in 3D survey. So but it does need some processing, yeah.
Yeah, so because the SLAM, while you are recording, it's doing it's just quickly showing you what you have mapped and what basically it's drawing a map where you are with the scanner. This helps you know what you've mapped and what you haven't. But then in order to make the data very accurate, you need to download it onto the computer, put it into their software. Each SLAM scanner comes with this software. and then that makes it more accurate. It calculates more accurately how you were moving with the scanner when you were doing the scanning.
Yeah. So
okay.
The next one, would you please introduce about the programs you used for managing point clouds and drawing?
Yeah, so we basically already touched on this subject. So yeah, we used 3D Survey, and we used in this case it was called Go Post software, which came with the StoneX SLAM scanner, just to get to the point cloud. And the next question is also related to this one. How do you upload panoramas to a project? So basically, if your SLAM scanner has the ability to record panoramas, you will typically have an option to export those panoramas along with the point cloud. So those panoramas are then automatically stored in the E57 file format. There are still, now there are so many SLAM scanners coming on the market. So we can maybe do a small, how is it called, teaser. We can already mention that we are preparing to release the next version. And in this one, we automatically imported the panoramas. So 3D Survey automatically imports panoramas from the E57 data format. So typically this is what is done. But if you have, for example, just a regular 360 camera and you have the positions and orientation of those panoramas, in the future version, it will probably be possible to import them from with a specialized importer. Because we're also adding these options just because there are so many different ways these panoramas are stored, so that you will get an option to import them also differently.
So there was one simple question. Can you define plane for walls, not just for floor plans? So vertical plane, I guess that's the question.
Yes, easy. So with a small trick though. So here you see that I drew basically. So here what I did was we already have the floor plan. Now let's say that I go back here into CAD and I will repeat that. So first we draw the line along this here. Now I want to create a vertical plane. So first thing I will do, I'll go here into CAD. I could use this point up here, but I will just draw it again. First, define a plane and create a vertical plane. Confirm it. Now I want to project this point vertically. I will go here and click on this endpoint like that. It creates a point up there. And now I will reset plane, define a new one, and I will select point here, point down there. Now it's still horizontal, and when I add the vertical, now we have the perfect vertical plane for this. And we can now confirm. And then, for example, if I wanted to extract if I wanted to draw this door here, I can now do that. Click here. So first go into line drawing, click here, enable the object UCS. Then we will get, this will be the height of our doors here, and it will go to here, and then back down to this. We will snap on this point, move it here, and this is now our doors. To make it better, we could put it onto a different layer actually.
To differentiate it from the
that's
walls.
why we make it red, like that.
And put it in the right layer. Right, great. So if we move on, we have a bit more technical question. So let me read it and you can answer. It would be best practice to accommodate common ground floor GCPs for both point cloud and photogrammetry using the same RTK provider and settings in order to minimize the minor displacement and time spent on manual alignment?
Yeah, so actually for this project, we did not touch on ground control points, but when we were outside, we did place some ground control points and we measured them with the GPS just to make sure that we get. But when we did the comparison in this case, the elevation difference between the model from the photogrammetry and with the SLAM device, I think it was within a few centimeters. So typically what we see, if you have a good RTK, there's about a centimeter or two accuracy offset between the measurements, which is what we usually expect from basically using GPS for georeferencing.
But I would say that's a safe approach to go, to have a backup.
Yes.
Okay, now Dirk is asking us, have you imported the raw scan data into 3D Survey or have you processed it in other software? So we basically already answered this one.
Yeah.
It's native software from StoneX in this case. I think all of those scanners come with the specific software to do that.
Raw data processing, because each one has different raw data, different ways they are stored, and they need to be processed different ways. Everyone has their own algorithms how to process the raw data to get out of them the best results possible.
And the next one, is there any other handheld SLAM scanners you would recommend? I'm very happy that Adam gave us this question because we're currently writing a SLAM scanners comparison, and there you will be able to read it and give our comparison. So, but basically, if we just quickly mention a few, Faro is also a decent one, and CHC now has also a good price performance scanner. Vid, would you, on top of your head, add?
There are so many different SLAM scanners, but I think we will do a webinar in future where we will discuss our experience with different ones. So one thing, we had a few people actually come into our office and show some of the scanners to us. Some give better results and some give less optimal results. I'm not sure, but because when you go through technical details, sometimes all things are not mentioned. I'm not 100% sure here yet, but a few models that we saw, when you went inside, you would not get accurate data. I think the reason was that they are missing that they make the scanners cheaper by leaving out the INS, so that's Inertial Navigation System Unit inside of the scanner, and they rely on cameras instead for doing this part of the job. So I did see some customers also send me data from their scanners, and for example, the data would, the vertical walls would not be vertical and these kind of things. I think we will try to investigate a bit more in detail in future and provide you more information on that subject in one of the future webinars.
It's still very growing and evolving market, so there's a lot of offer and a lot the quality is varying heavily. So we are quite happy with StoneX, and this one I think we can safely recommend. But yeah, we'll do more research on that in the future.
Is there any training package for those who are new to SLAM?
A good one.
There is not a whole training package yet, but we do have some webinars already on the subject. And I think we now typically do one webinar per month. As we said, we'll be focusing more on the SLAM data processing in the future as well.
So next question is, during the registration between MLS and UIV, have you only used GNSS RTK or have you used any other iterative algorithm?
In this one, no, we did not need to, but we did try to use the iterative closest point georeferencing algorithms on other projects we did in order to say this is the fixed point cloud and move the second point cloud and make it best fit the first one. We did try that before between different SLAM scans. We also tried that between photogrammetry and the laser scanning data. So I think the ICP, that's iterative closest points algorithms, they work best if you have two very similar data sources, but they also, for example, two leader scans. But in our test, it also works if you combine photogrammetry with the SLAM. In that case, it's important that you have high quality data inside.
Okay, so the next question sort of ties on that. If not georeferenced, can you adjust all data sets, photogrammetry and SLAM, terrestrial lidar, and GCP in 3D survey through user-defined alignment and at least squares on final solution?
Yes, you do that. So you would do that with the manual registration.
Would you care to? Yeah.
The thing is, in my project, I don't have both scans. So to show that, we would need here 2 point clouds, but this one is already joined.
Yeah, I can show you, but yeah, mine is also already joined, but still, I think for the understanding of it, I think we can show it. Okay, if I show my screen, so in this one, okay, so is it now sharing? Oh, maybe like this. Okay, so can you see the 3D survey screen?
Yeah, well, what I see is the PowerPoint.
Oh, sorry. Okay, so this one. Okay, so if we just imported this, we could go here to manual registration. And since these are pretty big point clouds, we have 380 million.
Yeah, so points. Actually this works best for this project. You actually need 32 gigabytes of memory in your laptop. Because of that, so here for the demonstration part, I was working with a little bit smaller section on the laptop.
It did open up.
Okay.
So what you would do here is you would import.
So what you would do, you would mark the same points onto different SLAM scans.
Those 2 point clouds. And you would just find identical points on them. So, okay, sorry, I guess I have some connection issues. So when you find those 3 ground control points or something, you simply press register here and it will align the 2 point clouds together. You could also use this option to import points from file if you have ground control points measured.
Perfect. And like that, and the registration is done in the least squares manner, so it does the best fit. If you have, for example, 6 identical points, it will find the 7 parameters of transformation between those 2 sets of points automatically.
Okay, so did we forget anything? Should we go to the next question?
We can continue to the next question. So Steve is asking, do you mark, for example, window heights measurements in 3D Survey 2 before exporting it to BIM software? Yes, they also mark the windows and these kind of things so that they were able to get the areas and volumes of the walls exactly. But this part was already done by one of the guys on the institute. Another question from second Steve is, which industry would use this kind of data the most? Why would I need to map interiors of structures? So
That's an intriguing. I guess construction is the obvious
but
answer.
also land surveyors for making floor plans of the for the building cadastre and making maps of the building cadastral map and these kind of things. So these are the ones we are most familiar with. But
And I would say also architects.
Yes.
To produce a digital twin, to also you can combine it with some renders. So you have as built and you know, existing state and maybe planned state. You can compare all these.
Okay, maybe we can go to the next question. What other SLAM scanners can you recommend, and would you have rough costs for the StoneX? We'll wait with the recommendation of the other SLAM scanners so that we don't make some mistake because we don't know them yet good enough, I would say. But about the rough costs for this StoneX, don't take my word 100% for it, but I think the price of the model that we used, I think it was a little bit over 30,000, maybe 32 or 33,000 euro.
Yeah.
But I think they also have another model, which is almost exactly the same, but it has just a little less powerful sensor, and I think that one costs a bit under 20,000, if I am correct.
Okay.
Good. Then
so
Felix,
how big was this project in gigabytes?
let me check. So my projects here, so it depends a little bit on how you process the point cloud. So initially the size was just under 9 gigabytes, but when I was showing how we were also working with the X-rays, and when we created normals, then the project size grew about to 14 gigabytes. So between 9 and 14 gigabyte project. So that is compressed data. When you open that project, it extracts, and then in memory, it comes to a bit over 30 gigabytes of memory. So because of that, I said that you need 32 gigabytes on your laptop to when you're doing the processing of this project.
This one's a bit big, yeah.
Okay, next question. Oof, we have a lot of them today. For the integration of UAV plus SLAM, the registration was based on feature-based or point-to-point? So in this case, the registration was done based on the GPS, on the RTK GPS. If you do the ICP, then it's done point-to-point, but it's comparing all the points in first point cloud to all the points in the second point cloud.
Okay, so the next one, if we just hurry through, how to remove noise and drifts when modeling?
So in this case, about noise reduction, there was a special checkbox used or a special tool. It's called denoise. You run that on the first iteration point cloud you get, and out you get point cloud with a lot less noise. Maybe if I just go back and quickly reshare my screen to check how much noise the point cloud has.
So that was basically
screen sharing.
That was done in the native StoneX app.
Yes. So here we see, if we go in and zoom in, maybe let's try to do it. So let's take the wall from the floor, for example. So here we have the points are a bit thicker. You see that on the denoisal algorithm, it works very good with the flat surfaces. So this is perfect for the insides of buildings like that. The point clouds come out quite sharp. For the second part, if you have issues with drift, with SLAM drift, what you can do, you can also add in ground control points to eliminate that drift if that's necessary. That's one way, or the other way is to make sure that you get RTK GPS every here and there, and that will also eliminate the drift.
Yeah, but if you fail at both of those, I'm afraid there's not much you can do. So make sure you have some backup in GCPs, and that you check that you go outside to have a RTK signal. This is your best scenario, best recipe to not drift.
So here's the question: have you calculated the registration error between UAV and MLS point cloud? Yes, we typically do that. Typically, we see about 2 centimeter difference, both in position and in elevation between the two data sets. You just need to make sure that you have good RTK both on your UAV data and also for your SLAM data. So one thing we did notice when doing the tests around here around our building is I did notice that if you go close to the building, you can experience a bit of multipath effect. So maybe, you know, if you do, just make sure that you have good GPS and don't walk too much with the SLAM scanner very close to the wall. You can also scan it from maybe 5 meters away. You will still get very good results on the walls.
Okay. So the next question is, what criteria did you use to filter the noise in the point cloud?
We use the default settings. I think it said there were some parameters. I don't remember them 100%. I know there was KNN, so that means how many nearest points to use. I think it was set to between, I think it was something like 15 nearest points. And there was parameter about standard deviation, which was set by default to 1.
So we just trusted the system.
Yeah.
Okay. Have you integrated spherical images from Leica BLK2Go to texture model?
3D? Not to texture the 3D model, right?
Mm-hmm.
But the next version, I think it will have support for Leica BLK spherical images.
Okay, this SLAM scanner information would be useful. When will you be publishing this information? The SLAM scanner information?
I think this refers to the webinar on the SLAM scanners and these kind of things. And
yeah.
Posts.
Yeah, the post, the showcase, the case study that we're doing will be posted soon. You'll get, I think, a newsletter with the link soon after it's published.
Okay.
So is there a size limit for the processing in 3D survey? Can it process models of 30 gigabytes or even 50 gigabytes? Does it support dual RTX 4090? So I can answer for the final part. The dual graphics card system is supported, yes. With how about the processing of,
okay. So the size limit is typically related to the hardware PC and how we manage the data. So when we are doing the processing, typically we use all the point cloud points in the RAM. So there are different approaches, but basically when processing data, there are some restrictions. If you have, so for example, this now is different between if you're doing photogrammetry or SLAM, because with photogrammetry, we also do the processing of images to make the point clouds. There, basically, the processing difficulty rises quadratically with the number of images. So sometimes it makes sense, you know, if you have thousands of images, just to split the project down so that you have, for example, if you have a powerful computer, so that you have a few projects with up to 5,000 images or something like that, if you need to have big projects. But also in this one, we showed that, you know, in order to get a very detailed model, sometimes it's not 100% necessary to have thousands of images, because here for us 200 was enough. Of course, if your area is big, you will need to have a lot of images. But in that case, you know, with one drone flight, you will maybe create 500 images. So if you're combining 5,000 images, that means that you're putting together data from 10 different flights. The problem with that is between those flights, sometimes shadows can move. It will take a few hours between different flights. When you merge them, some things can change there. So sometimes that will also be the limitation. Why not to put just all the images into one project? But it might make more sense to process the projects separately.
Yeah, and if you're working with huge point clouds, you can also reduce them.
Yes.
It's a simple feature in 3D Survey.
Also, let's say that you have 1 billion points. You can never see 1 billion points with your eye because you don't have such resolution. So, you can also just reduce them. So here, for example, I think actually, so the project initially was 700 million points, and then we so that it was able to be run on the 32 gigabytes, we actually downsampled it to 3,500 million points.
Yeah. Okay, should we move on?
Here is thanks, and the least squares adjustment report would be provided. Thank you. So actually, when you do the manual registration or automatic registration, there is also a checkbox to create report on the calculation. The report just gives you the points and the parameters and how they were calculating.
Yeah, and the next question came from Blair. So what kind of accuracy do we believe we achieved inside with the SLAM in terms of centimeters?
I think we were in approximately 2 to 3 centimeters range. So according to the technical data sheet, it says for georeferencing insight, I know that there was this information in here. Relative accuracy, it says up to 6 millimeters. I would say that we can comfortably say that you can get to a few centimeter accuracy, maybe 2 or 3 centimeters for sure.
It depends on the environment, of course, but the point clouds were very low on noise, I would say.
Yes.
And even in this case, where the environment was not ideal, the lowest level was the cellar, so it had very little light. Practically every few meters there was a small window, or not even a window, like an air shaft, and it still gave us a very good point cloud. The colors are obviously a bit weak, but the accuracy remained good.
Yeah, so here the interesting thing is, so the SLAM actually works pretty well also in darkness because it's an active sensor, it has its own laser. Basically, so it also works in darkness pretty good. So maybe on this screenshot, you can see a little bit of the bottom floor. It's completely black on the point cloud.
Okay, next question is, would this software help with ceiling scans, pipes and ducts, or is it just floor plans? I mean, of course.
Yes, so you can also use it on basically you can use it to map insides of the buildings very fast and accurately enough, I would say.
And I think we just had a user that did sewers scanning and mapping pipes. So I think if someone can pull that off, anything goes basically.
Okay, we're slowly getting to the end of our question list. So what GPU do you use exactly for the calculations? A good question. So not sure which, so maybe this GPU they used on this calculation was a little bit older one, 3060, GeForce 3060. If you consider buying a new GPU for right now, I would recommend GeForce 5060 GPU. So this is based on the performance, the price performance ratio and other. So we did see that if you, for example, buy the most expensive 5090 GPU, it will be faster than 5060, but it will cost approximately 4 times as much, but it will not be 4 times faster. So in that case, it's better to buy 2 5060 GPUs, and you would get double speed, double processing speed as you would with one, and the cost is double, so it's linear. So this is the GPU that we are recommending to our customers. And definitely our recommendation is not to go with the Quadro.
Yeah, that's what I wanted to add. Don't go with Quadro, never.
Well,
it's just too expensive for very little effect.
Yes.
Okay, I think we got to the final question.
How can you avoid introducing errors when merging multiple scans? I think this is a question for the webinar on the merging multiple scans into one project. But
the webinar of its own, yeah.
we did that in the past with the terrestrial SLAM lidars. So how we went about it, we used the ICP algorithm to make sure that we got it correctly. Then one trick you can do in 3D survey, we did it like that. We colored different point clouds differently. So that one would be blue, one would be red, one would be green, etc. Then we would do a cross bounding box and just take the very narrow slice, and then we would just look at it and we would see if we get any double walls. And double walls would be indication of an error in georeferencing. So that way you can see if one is not correctly georeferenced, then you can, if you see errors there, you can then add some additional data there and try to get it to georeference properly. So basically, I would do the visual inspection of the point clouds, georeference together, and make sure that one is not giving different results as the others, so that one point cloud doesn't have different position like that.
Thank you, Wid. I would like to add that a lot of questions today asked were actually addressed in our webinar focusing on the scan module. So maybe check that out as well. There we focused a bit more on those alignments and X-ray views drawing and all this stuff that comes with the module. And for those who haven't tried 3D survey yet, I recommend you go on our website, get a free trial, because this also comes with a scan module enabled for 2 weeks, and you can check out all the potential. You can see the full performance of the software and see if it fits your needs. And if it doesn't, please shoot us an email and we'll work something out. That's about it from my side. Wid, would you like to add something else?
I'd like to thank you all for coming to this webinar. I see that most of you stayed up until the end. So in the end, it took us 1.5 hours. So that shows that this is really an interesting piece of technology. Thank you for staying with us, and see you in the next one.
Yeah.
Bye-bye.
See you next time. Bye-bye.